In the last module, we defined the notion of propositions. Today, what we're going to do is we're going to talk about how we can combine these propositions using different operators, or also known as connectives. We'll use these notations. We'll use lowercase letters, generally P, Q, R, S, to stand for propositions. So, for example, we might say that proposition P stands for Lansing is the capital of Michigan. And basically, we will write it as P is a proposition, and oh, by the way, it is capturing this information. Lansing is the capital of Michigan. We are going to read this as P is a proposition that Lansing is the capital of Michigan. Once again, propositions may be true, they may be false, but what is important is they must be unambiguous and they must be declarative statements. Now, once we have some propositions, we can create new propositions by combining the propositions that we have, by combining them by what is known as logical operators or connectives. The first operator that we're going to look at is negation. Then we'll look at conjunction, then disjunction or, exclusive or, then we'll look at conditional or implications, and the first operator we'll define is negation. The definition of negation is as follows. Let P be a proposition. The negation of P, we write this as not P. The not symbol looks like this, followed by the proposition P. So not P is a proposition that says it is not the case that P, that means if P is true, not P is false. If P is false, not P is true. Let's look at an example. Let's say P is the proposition that says Lansing is the capital of Michigan. Not P would be, it is not the case that Lansing is capital of Michigan. And we could rewrite this as Lansing is not the capital of Michigan. Every time we define an operator, we are going to write the truth table for it. The truth table is basically going to describe the input-output relation. So it's going to say if I have this as the input proposition, then this is going to be the output proposition. So it displays the relationship between the truth values of different propositions in this manner. So this is the truth table for not P. The truth table for not P, it's going to have two entries. Because not P has one input, namely P, it can take two possible values, true or false. So we have two values, either P is true or P is false, and therefore we are going to have two possible inputs, and we are going to figure out what the value of the output is going to be for each of them. So if P is true, not P is going to be false. Because not P is capturing this notion that it's not the case that P is. So if P is true, not P is going to be false. If P is false, not P is going to be true. So this is something I'm going to call an important slide. Make sure that you remember this. This is something that will come in handy for a lot of things that we are going to do in the future. It looks very simple, it is, but it's something that is going to be important. And I'll be marking some of these slides like this in the same fashion throughout these modules. One second, we have reached the check before you go ahead slide. So here, suppose P is true. What is the value of not P? What is the value of not P? What is the value of not 1 less than 2? Now, one thing I want to point out is whenever the answer is unique, as in there are not multiple answers to that question, or the answer is not sort of describe something, I would give the answer at the bottom of the video over here. You can check your answers. If it doesn't match, be sure to check with the TA or with me to see where the confusion lies. One important thing, remember that either P or not P has to be true. Exactly one of them has to be true. Both of them cannot be true simultaneously. Both of them cannot be false simultaneously. Go ahead to the next operator only if you have understood this.